In programming, a variable is a named storage location that holds a value. It can be thought of as a box or a container that stores information. Just like you can put different items in a box, a variable can hold different types of data such as numbers, text, or more complex structures. Variables are used to store and manipulate data during the execution of a program. They allow you to assign values, retrieve values, and perform operations on those values. By using variables, you can work with data dynamically and write flexible and reusable code. Here's an analogy to help you understand the concept of variables as a box. Imagine you have a box labeled fruit. You can put different fruits like apples, oranges, or bananas in the box. In programming, you would define a variable called fruit and assign a specific value to it. For example, fruit is assigned a value apple. Later in the program, you can retrieve the value of the variable and perform operations on it. For instance, you might want to check if the fruit variable contains the string apple, and then perform a specific action based on that condition. For example, if fruit is equals to string apple, print it's an apple, else print it's not an apple. In this example, the variable fruit acts as a container that holds the value apple. By comparing the values of the variable to the string apple, you can determine the path of the execution in your program. Variables are crucial in programming as they provide a way to store and manipulate data, enabling you to create dynamic, interactive applications. Right, let's make another example. Once upon a time, in a digital kingdom of Codeville, there was a clever programmer named Alice. Alice was tasked with creating a program to manage a magical potion shop. To accomplish this, she had to understand and utilize variables. Alice began her endeavor by envisioning the shop's inventory. She knew that each potion bottle had a unique name, quantity, and price. To represent this information in her program, Alice decided to use variables. She created a variable called potion name to store the name of a potion, potion quantity to hold the number of bottles available, and potion price to store the price of each bottle. These variables acted as placeholders for the potion data. As the program executed, Alice assigned specific values to the variables. For instance, she set potion name to healing elixir, potion quantity to 10, and potion price to 5 gold coins. Alice's program allowed customers to purchase potions, and as they did, the variables updated. For example, if a customer bought 3 bottles of the healing elixir, Alice subtracted 3 from potion quantity to reflect the reduced stock. Furthermore, Alice employed variables to perform calculations. She created variables called total price to store the total cost of customers' purchase by multiplying potion quantity by potion price and assigning the results to total price. Alice could calculate the correct amount owed by the customer. Additionally, Alice used variables to compare data. For instance, she employed an if statement to check if the quantity of a particular potion was running low. If potion quantity fell below a certain threshold, Alice would be alerted to restock the potion. Thanks to variables, Alice successfully created a program that efficiently managed the magical potion shop. They allowed her to store and update data dynamically, perform calculations, and make decisions based on conditions. In the end, Alice's program helped the potion shop thrive, and it was all made possible through the clever use of variables in programming. That's all for now for variables in programming. And don't forget to like and subscribe so that we can provide you with more content. Thank you for watching.